In today's session, we get to look at what we call even and odd functions. So we'll start straight away with what an even function is. Now, an even function is one where when you plug in negative x in the place of x, the same function will return. We shall use illustrations to paint the picture clearer regarding this. So let's look at this. We have a function f of x is going to be equal to x squared. Now the input value here is x, and it's giving us x squared. So now if in the place of x we put 4, this is going to become 4 squared. That's going to give us 16. When it gives us 16, we go and do the same thing and put a negative 4 in the previous place. When you put a negative of the same function here, it's going to become negative 4 squared, and it's still going to give us the same number 16. Now, because when we plug in a negative value, it's going to give us the same answer, 16. This makes f of x being equal to x squared an even function. This is the other illustration. We are having another function, f of x is given by x squared plus 3. Now, let's choose a number 5. When x is 5, we put 5 in the input there. Of course, when x is 5, here it's going to become 5 squared plus 3. 5 squared is 25 plus 3, giving us 28. That is when we put in the place of x 5. So now let's go ahead and put negative 5 in that same place. That is what we did here. When x is negative 5, when you put negative 5, it's going to become negative 5 squared plus 3. It's still giving us 25 plus 3, giving us 28. Now when we plugged in a positive 5, it gave us 28. When we plugged in a negative 5, it still gave us 28. So that property makes this an even function. Again, an even function is one where when you plug in a negative x in the place of x, the same function will return. And that is exactly what we mean. All even functions are symmetric about the y-axis. Now, by saying that they are symmetric about the y-axis, it's like saying the y-axis is like a mirror, or it's a line that divides the function into two equal parts. Let's take a look at a few graphs to illustrate this further. Now, if you look at this graph, this is more of a quadratic graph. This quadratic graph is an even function. Why is it an even function? If you see this quadratic graph, it is symmetric about the y-axis. In other words, the y-axis divides it into two equal parts. So it is symmetrical about the y-axis. This is what we mean. Now, when it comes to odd functions, and it's a bit different for odd functions, that instead a negative value is going to be returned when we change. Let's take a look. We have the function f of x is given by x to the power 3. So let's make x be equal to 2. When we put 2 in there, when the input value is 2, we are going to get here is 2 to the power 3, giving us 8. So now in the same place, we are going to put negative 2 here. When you put negative 2 to the power 3 is going to give us negative 8. So now with an odd function, when we put a value of x in the place of value of x, when we put in a negative value in the place of x, like we have done here, you're going to end up coming with a negative answer, or a negative function. So that brings us to that relation for odd functions, so that brings us to that relation regarding odd functions, that for odd functions, this is exactly what happens. That when we put a negative answer, actually, this is more accurately put when we say that when we put a negative value in there, it's going to return a negative, like that. And of course, this negative, if you multiply by negative on both sides, it turns out to be this expression. So that is for odd functions. This is how the relation comes out about for odd functions. That when you put in the place of x, you put a negative x, it's going to return this as your answer. Now, it's important also to note that odd functions have a rotational symmetry about the origin. By rotational symmetry, it means that if I was to turn this thing, if this was my center, and I was to turn this graph by 80 degrees, it would still look exactly in the same, it would have the same shape if I turned it 80 degrees. When this is my center, it would look the same. So that is what we are calling rotational symmetry. So they have a rotational symmetry about the origin. Now take note, there are some functions whereby the conditions that we've been discussing earlier are not met. They do not meet the condition for it to be an odd, or they do not meet the condition for it to be an even function. Now, of course, if you encounter a scenario where neither of those conditions are met, it means that that function is neither odd nor even. But also we said that even functions are symmetrical about the x, and odd functions are symmetrical about the origin. We are going to go through a series of graphs to try and identify which graph is representing an even function, which graph is representing an odd function, and which graph is representing neither of the two. So the first graph here is a quadratic graph. Of course, this is symmetrical about this axis. It's symmetrical, so this makes it an even function. It's a function. It's an even function. Then if you look at this thing, it is not symmetrical about the x-axis, and it is also not having any rotational symmetry about the origin. So this one is neither odd nor even. Then we have this one right here. It's not symmetrical about the y-axis. In other words, this y-axis is not splitting it into two equal parts, and also it's not having a rotational symmetry about the origin. So this one is neither. It's neither odd or nor even. Looking at this one, if you look at the y-axis splits it into two equal parts, meaning it's having a symmetry about the y-axis. So this one is an even function. This one right here, it's not symmetrical about the y-axis. It is not having a rotational symmetry about the x-axis, about the origin, meaning this one also is neither odd nor even. No, it's neither odd nor even. Looking at this graph right here, it is having, if you look at the y-axis, it splits it into two equal parts, or into two parts that are identical to each other. So it is having, it is symmetrical about the y-axis, meaning that this represents an even function. This one right here is having no rotational symmetry, and it is not symmetrical about the y-axis. So this one is neither odd nor even. This one right here, it's not symmetrical about the y-axis, meaning the y-axis is not dividing it into two, and also, but it's having a rotational symmetry about the origin. In other words, if you're to turn this into 180 degrees, it would look exactly the same. If you turn this into 180 degrees, it would look exactly the same. So it means that this is an odd function, since it's having a rotational symmetry about the origin. If you look at this one, it's not having a rotational symmetry about the origin, and it is not having a symmetry about the y-axis. It's not symmetrical about the y-axis, so meaning this one is neither odd nor even. Then looking at this function, it is symmetrical about the y-axis. In other words, this and that, it's more like a mirror. This is reflected in that direction. So it is symmetrical about the y-axis, so this makes it an even function. Looking at this one is symmetrical about the origin. In other words, if I was to rotate this graph by 180 degrees, it would look exactly the same. So because it is symmetrical about the origin, it is an odd function. This one is not symmetrical. It's neither symmetrical about the y-axis. It's also not symmetrical about the origin. So this one is neither odd nor even. So we have taken note of that. When we want to identify graphs that are representing odd or even functions, the key thing to take note of here is this, that when it comes to odd functions are symmetrical about the origin, or they have a rotational symmetry about the origin, And when it comes to even functions are symmetrical about the y-axis. So we have some numbers here to work out. We are required to classify each of the following as even, or odd, or neither. And from there, of course, we are not going to draw graphs. We are going to calculate them and see which ones are even, which ones are odd, and which ones are neither of the two. We shall start with part A. Now let us be reminded, first of all, that when it is for an even function, when we plug in a negative here, it's going to return the same function. When it is an odd, when we plug in a negative right there, it is supposed to return something like that, like we had seen earlier. Let's take note of this as we get started. We have our part A here as f of x is giving us x to the power 4 minus x squared. So meaning that f of negative x means it's going to give us negative x to the power 4 minus negative x to the power 2. And of course, negative x to the power 4 is still going to give us x to the power 4 minus negative x to the power 2 is still giving us x. So you realize that when we plugged in a negative, it still gave us this x to the power 4 minus x, which x to the power 4 minus x is f of x. In other words, here, when we plugged in f negative x, it produced this, which is this. It produced f of x. So this means that this is an even function. That is how we arrive to that conclusion that part A is an even function. The function is part B, f of x is 3x squared minus 5x. That's the function. So let's plug in a negative here and we see what we get. So f of negative x is going to give us 3 into negative x squared minus 5 into negative x. So this is to the power 3, it's 3x cubed, so this is to the power 3 right there. So of course here 3 into negative x to the power 3. Negative x to the power 3 is going to give us negative 3x to the power 3 minus 5 times negative x gives us negative 5x, like that. And now there, if you're to put this negative outside, it becomes negative outside the brackets into 3x cubed minus 5x. And if you notice that this is going to become minus, and what is in the brackets here is 3x cubed, which is 3x cubed minus 5x minus 5x. This is minus f of x. So if you notice that when we plugged in the negative, when we plugged in f of negative x, we ended up with that. So this is a property for odd functions. So it means that this is an odd function. So part C, we are having f of x is giving us 2x plus 5. So let's plug in a negative here. A negative, that is f of negative x, is definitely going to give us 2 times negative x plus 5. And then definitely we are going to end up with negative 2x plus 5. Now definitely this it does not satisfy any of these conditions. This does not satisfy any of these conditions. It does not satisfy this condition. It does not satisfy this condition. So what that means that part C, the function part C is neither odd. It's neither odd nor even. Now we have a function part D. The function D is f of x is equal to 3x squared minus 4x. Let's plug in the negative. F of negative x, what do we get? Does it return the same function? That's going to become 3 into negative x squared minus 4 into negative x. and this is going to become, of course, negative x squared is going to still giving us 3x minus negative x, of course it's minus negative 4. This is more like 3x plus 4. That is f of negative x giving us that. Now you realize that this and this is squared, that is squared. Of course, this and so you realize that there is no connection between this function and that function in terms of what we call an odd number or an even number, or in terms of what we call an odd function and an even function. So what does that mean? It means that this is neither odd nor even. So what kind of conclusion are we coming up to here when it comes to odd functions and even functions? This is the conclusion. For even functions, when I plug in a negative x, this is the original function. If I plug in a negative x and my working is such that it is going to bring back the original function, when I plug in a negative x, it means that that is an even function. That when I plug in a negative x, it brings back the original function. Likewise, for odd functions, if I plug in a negative, this is the original function. If I plug in a negative right there, and when I plug in a negative in this function and I work it out, and it comes out that it's going to bring a negative of the original function, a negative times the original function, which is this one. It means that, that is in this case, that if I get a negative, when I put in a negative in the original function, it's going to give me negative the original function, then that qualifies to be an odd function. Now, if I work it out like in these last two numbers, and it so happens to be that neither of these two conditions of the odd function and the even function are met, then that function is neither odd nor even. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.